This video will work through problem 14.7 of Gapenski's Healthcare Finance, 6th edition. Okay, given the fact that this is a somewhat lengthy calculation to do it by hand, I'm going to go ahead and do it in Excel. You could still do it by hand, and that would be fine. And for my students, you might have to do this by hand on an exam. So you need to understand what you're doing. All right, so California Health Center is a for-profit hospital, and they're trying to decide if they want to buy some new diagnostic equipment. And so we're going to work out, initially we're going to work out what their net cash flows are. So part A is to work out net cash flows over 5 years, and then part B is to project the NPV and IRR. So we'll do both of those, but we're going to start with calculating the cash flows. And so I've laid out the format per the guidance in the problem. I've changed the names, modified the names just a tiny bit, but regardless, it should be fine. So we have at time zero, we're going to go ahead and buy the equipment. So the equipment costs $600,000. So it's going to be a negative cash flow of $600,000. And let me, right now I'm going to go ahead and just change all the entries to accounting. So at time zero, the only thing we're doing at time zero is spending $600,000. So our net cash flow then is going to equal, for that year is going to equal negative $600,000. Okay, then in time 1 through 5, so going forward the following years, we won't have any additional equipment costs. So this is a relatively simple application here. So we do that one-time investment. Then we're looking at net revenues. And so if you go to the problem, it says, it gives you some information about the number of times that the equipment is going to be used per day, times the number of days it's going to be active, times the net expected revenue per scan. And so if you multiply all that together, you get $300,000. So we're expecting an annual net revenue out of the gate in the first year of $300,000. Then we're given some other information. Labor and maintenance is expected to be $100,000. So 100. Utilities will be 10,000. Overhead, let's see. Incremental overhead of 5,000. So it says overhead is going to increase by $5,000 in year 1. So that's 5,000. And then the cost of expendable supplies is expected to average $5 per procedure during the first year. So we need to know how many procedures. So we're going to do, so it's going to be a little bit of a calculation, but it's going to equal $5 per procedure times 15 procedures per day times 250 days per year. So that gives us 18,750. And then what else have we got? We've got to get our depreciation. And so we're going to use Macker's depreciation, and they give us it's going to be 5-year equipment. So in the first year, we allocate ourselves 20% of the value, the purchase value. So it's going to be 0.2 times our purchase price. And since we're doing everything, all our other expenses in a positive, I'm going to change that to a positive as well by multiplying it by making that 20% be negative. So all of my expenses are positive, which means that to calculate my operating income, I'm going to take my $300,000 in net revenue minus the sum of the rest of my expenses, and I get 46,250. So now I'm going to take, so this is my operating income yeah. So now is the taxable income, and let's see, our tax rate is 40%. So we're going to pay 40% on our 46,000. So that's going to be, I'm going to say equals 0.4 times the operating income, which is 18.5. And to get my net operating income, I'm just going to subtract the taxes from my operating income. And so my uh, net operating income then is 27,750. Now, that is not cash flow, though, right? Because depreciation is not a cash expense. So I'm going to take my net operating income and I'm going to add back the depreciation that I charged myself to actually get my cash. No, sorry. I want to actually put the depreciation in there. I'm not following the format. Okay, so now to get my net cash flow, I'm going to take, my net operating income plus the depreciation, and that gives me a net cash flow of 147. And notice that we don't have any salvage this year. That's going to happen at the end of year 5. So we're just going to ignore that. Okay, so now moving forward, we're going to assume a 5% increase per year of inflation, and that's going to apply to everything except for what? Depreciation, right? So going forward, I'm just going to take the initial amount times 1.05, right? And therefore my net revenues are going to increase by 5% each year, and I should be able to just copy that across. And now I have all of my net revenues, right, projected out because I expect that they're going to increase by 5% per year. Unfortunately, so do my costs. So this is relatively straightforward here. I'm just going to do the same formula. I'm going to take the amount of expense times 1.05 to represent inflation. And I can basically copy that all the way down, except excluding depreciation, right? So, yep, all looks good. And then I can just copy that across. So this is the beauty, of course, of doing it in Excel as opposed to doing it manually. You can't just copy across if you're doing it manually. But so that's the kind of the revenues and non-depreciation expenses. We have to, in order to do depreciation, we're going to have to kind of manually enter this because Macros changes each year, and I can't just plug a formula in. Well, I could, but it's easier to just follow the depreciation schedule that's provided to us in the textbook. So year 2 depreciation is 32% of the purchase price. And I said I wanted to make that a positive number. So since I'm going to be multiplying it by a negative number, I need to make that a negative number. And then, I guess I did copy it down. And then in year 3, it's going to be 19%. So negative 19 times the purchase price. And I guess Excel is wanting to fill in for me. So thank you, Excel. Don't need that. And then in the 4th year, it's 12% times the purchase price. And then in the 5th year, it is negative 0.11, 11% times the purchase price. So those are our depreciation. Those are our depreciation numbers. And so now we can go ahead and just copy across our operating income formula. And let's see, everything looks good. Okay. And then taxes, still the same. Is also, we can just use those as a formula. And then net operating income. And then depreciation, let's see, yeah, we did a equals, so we should be able to just copy that across. And then our net cash flow should be able to copy that across. And okay, we're not quite done. We have to do one more little tweak with year 5, and that is working out the salvage value. Okay, so we're almost there. Okay, so if this was a not-for-profit, the calculating the salvage value would be relatively simple, and the salvage value would simply be the $200,000 that we're able to get when we sell the equipment according to the problem. However, this is not a not-for-profit, and we have to pay taxes on the salvage value for any amount that is not currently depreciated. So the first thing we have to do is calculate how much depreciation or how much book value is left after we include the depreciation. So first I want to find out how much depreciation I've taken so far this year, so far in this 5-year period. So I've taken $564,000 in depreciation. So I'm going to do these little calculations out here on the side, right? Just to make this a little more obvious. And then so we have taken $564,000 in depreciation. So the book value of our equipment is now $600,000, right? Was our original purchase price, minus the 564. So we get 600 minus 564 is, so we've got the book value of our equipment is $36,000. Now we're going to sell the equipment for $200,000. So the taxable amount, the profit that we're making on this sale is $200,000 minus the $36,000 in book value is $164. And so we have to pay taxes on the $164. And so since we are in the 40% tax brackets, 0.4 times 164 is going to be $65,600. Okay, so we're going to pay $65,600 in taxes on the $200,000 sale. So how much is our net salvage value? It's going to be $200,000 minus the $65,600 in taxes, which gives us $134,400. Okay, I'm just going to copy and paste that back in as a fixed amount, and then I can delete all this stuff, right? Because it's not pretty. Okay, now we've got to fix our final number here. So we have net income of 81 plus depreciation of 66 plus our salvage value. Oh, it's not going to let me do that. Let's just do equals sum. So I just summed the net operating income. I added back the depreciation, the non-cash expense that we took up here, as well as the salvage value. And so our final net cash flow in year 5 is actually $282,000. So that is part A. And so now we need to calculate the project's NPV and IRR. Okay, so net present value is going to be based on the cost of capital, which is 10%. So we're going to take the initial purchase of $600,000, and we're going to add to it the present value of the cash flows, of the cash inflows, discounted at 10%. And we get 74,904, right? So I'm going to round that. Okay, so that's one way to do it. Another way would be to do it kind of manually, where you could, discount each of these. If you're using your calculator, you could use the cash flow register, right? And so you would plug in CF 0 would be negative 600, and then CO1 would be 147,750, CO2 would be 181,538, and so on. And then you'd type in NPV, set I equal to 10%, and then you'd calculate NPV. And then kind of the manual way, the other manual way you could do it is you could say, well, my cost of capital is 10%, right? And so I could say, what is the present value of each of these cash flows? Let's see. So the present value, PV of the CF, well, the present value of the purchase, because it happens at time 0, is itself. And then the present value of the first year's cash flows is 1 plus the discount rate raised to the number of years it's being discounted back, which is 1. And so we got 134,318. And let me just lock that reference to my interest rate over here, right, to my discount rate. And then I could just copy that formula over to the right. And let's convert these all to not having any decimals. And then then I can get my NPV by simply summing that row. And you can see I get the same result, right? So one was I used the NPV formula. This I do a little more manually, calculating the actual entries. All right, then IRR is pretty straightforward. You just do IR equals IRR, and then you just highlight all of the cash flows. So be careful, don't use your PV of cash flows, because that won't work. It won't give you the right number. It'll work, it won't give you the right number. So the IRR is 14%. Our text wants us to give it a decimal, so 14.4%. And then you could also calculate the IRR manually using GoalSeek, which I just get a kick out of doing, so I'm going to do it. And to do that, you have to figure out how to set the NPV equal to 0. So I'm going to manipulate the discount rate such that my NPV is equal to 0, because IRR by definition is the discount rate that would cause NPV to equal 0, right? So I've already done most of the work by setting it up the way I did. So I simply say that I want to go to GoalSeek, data, what if analysis, GoalSeek, and I want to set the cell where I did the calculations, right, that used this line. I'm going to set that equal to 0. So I'm going to set my NPV equal to 0. And I'm going to set it equal to 0 by manipulating the discount rate. And so I say, oh, I did a formula here kind of by accident. So, all right, one more time. Wasn't thinking when I did that. What if analysis, GoalSeek. I'm going to set that NPV to 0 by manipulating the cost of capital, which is our discount rate. So I say go, and we get 14.398. So our other version here is 14.398, which if we convert to a percent, you can see we get the exact same result, just using a little more manipulation. So that is part B. And so that is 14.7.